Welcome to the hands-on ASP.NET Web API course where you will learn creating a RESTful Web API using ASP.NET Core through a step-by-step approach. My name is Praveen from codewithpraveen.com, your instructor for this course. I had started my career at Honeywell that spanned for 10 years on product development based on csharp.NET. Currently, for the last 5 years, I have been working in the security domain for an access control product based on the .NET technology. I designed this course for anyone seeking to use ASP.NET Core for your next Web API project. By the end of this course, you will be able to confidently use the ASP.NET Core Web API at your current job. I have done the heavy weight of researching and organizing the topics so that you don't need to do that. We will follow the method of implementing an API for a college management system that will help you to grasp the new concepts better by applying the learnings you gain from this course. Some of the topics you learn include an overview of Web APIs in ASP.NET Core, Web API request workflow, HTTP status codes, mastering API controller, building a new Web API from scratch, learn API return types, namely action result of t, and async await, techniques to improve your Web API project using AutoMapper, build Web API operations such as get, post, put, and delete for collections as well as individual items, implementing association APIs, and so on. As a prerequisite, basic knowledge of designing RESTful APIs and basic knowledge of ASP.NET Core and ASP.NET Core MVC is expected. In case you are interested in these topics, you can find the related courses under my profile. I designed this course for backend web developers as well as software architects who want to efficiently implement web APIs using ASP.NET Core. In this section, Getting Started, we'll look at some of the topics that cover the basics of API. First, you will have an overview of Web API requests that show how a typical client and server workflow takes place. Next, you will get to know the most common API operations that an API developer typically uses. Next, you will get an overview of the commonly used HTTP status codes. This is followed by an overview of the CMS Open API specification document for one of the systems we are going to develop, namely College Management System, shortly CMS. We then move to step 1, wherein we will create a new Web API project for the CMS Web API project. Finally, we look at the different parts of a Web API project. Let's get started with the first topic, overview of Web API request workflow. In this first topic, you'll get an overview of the workflow of a typical Web API request. This simple diagram shows the typical client and server's HTTP communication. We have a client that is sending a request to the server. The server processes the request and then sends a response to the client. This is a very simple flow. Let's see what happens in the case of a successful request. Let's say the client is going to get the list of courses. The HTTP request is considered as a GET request for /courses path. This request is going to get the list of all courses available in the system. In this case, GET is considered as a method and /courses is considered as a resource or a URL. The server is going to process this request by fetching the list of courses from the database through a database repository, form them into a specific data model collection, and then respond to the client. The server will then return an HTTP response along with the result. In this example, it returns course 1, course 2, course 3, and so on. You can also notice that the response is 200 OK, which is known as HTTP status code. We will cover this shortly in another lecture. In this case, since it is going to be a successful response, it has returned a status code, namely 200, which is considered as successful execution. Let's see what happens in the case of a failed HTTP request. The client sends a request, namely get/courses, to get all the courses available in the system. Let's say during the execution at the server side, something has failed. For example, the database connectivity has failed, or while forming the collection from the database objects, some exception has occurred and it has to give that error information to the client. In such a case, We call it an internal server error, and the server is going to return the HTTP status code 500. The client knows that something has happened on the server, and then it can decide whether to send the request again or handle it in a different manner. Having known about that request response cycle, next let's have an overview of the operations that are involved in a typical HTTP request. We will cover that next. In this lecture, we will look at some of the common HTTP operations which are predominantly used by most API developers. First, what are operations? Operations are actions that are taken on the resource. In the previous example, the course was the resource. The actions that you are going to take on that course resource are referred to as operations. Note that operations are also called as verbs or methods. Next, let us dig into the different types of operations that are commonly used by API developers. These are the most 5 common important operations that you need to be aware of. They are get, post, put, delete, and patch. We'll go through each of these HTTP operations for their purpose and their typical usage. To begin with, we have the HTTP GET operation. We had briefly covered this GET operation in the previous lecture. The whole purpose of this GET operation is to retrieve details of a resource. This is the most common operation that is predominantly used by most of the API. Mostly, you have to get all the details of a resource in your database and you want to expose the API so that the third party or any other clients can retrieve these details. Hence, among all the operations, the GET operation is the most important and the most popular operation. Once the server processes the GET HTTP operation, it is going to return the details in the body of the response. Next, we have the HTTP POST operation. This operation is used to create a new resource on the server side. For example, for courses resource, to create or add a new course to the system, we use the POST operation. In this case, the body of the request is going to contain all the details required to create that specific request. Hence, the client needs to pass all the details required to create a new resource by providing these details in the body of the request. Finally, sometimes the POST operation is used to trigger some actions that don't involve creating a new resource. For example, say you want to restart the server. Although the resource in this case is a server, the restart is not a typical operation as it does not fall under the RESTful API format. You are taking an action that is a very generic functional API. In such cases, many API developers use POST operation to denote such cases. Next, we have the HTTP PUT operation. This operation is used to update the details of any of the resources that are already available on the server. Since it's going to update an existing resource, that resource should be present in the server when you trigger this action. Otherwise, the server can be implemented in such a way as to return a corresponding error code. For example, 404 not found or simply 400 for any client-side errors. Moreover, just like the POST operation, sometimes the PUT operation is also used to create a new resource in the case the resource does not exist. Don't get confused with the POST operation. The POST operation is mostly to create a new resource. The PUT operation is to update an existing resource if it exists, otherwise create a new resource. It all depends on the API developer. Some developers prefer to use the PUT operation for updating an existing resource, but for some developers, they also want to support creating a new resource if it does not exist. The body of the request is going to provide all the required details. Next, we have the HTTP delete operation. The purpose of the delete operation is to remove an existing resource from the server. You will be providing just the ID of the item that you need to delete. You need to be very careful when you are supporting this operation. You have to do proper validation with that ID that exists and whether the client has appropriate authorization to delete the resource. Finally, we have the HTTP patch operation. The patch operation is used to update a resource partially. In case you have an existing resource and you would like to update only part of the resource, then you can consider using patch operation. The difference between patch and put is that the put operation updates all the resource details, whereas the patch operation updates only part of the resource. The body of the request contains the partial details that needs to be updated. Once you have understood HTTP operation, you need to know about HTTP status codes. A strong understanding of all these concepts will help you immensely when we get to implementing Web API in the later part of this course. Let's cover HTTP status codes next. The HTTP status code refers to the unique code that is written by the server for every HTTP request. These status codes are going to show us the final result of the HTTP request that has been made, whether the request has succeeded or failed. Choosing the right status code is very important when you are designing and implementing the API operations. This table summarizes the main categories of HTTP status codes. They are also called classes. They are categorized according to the type of HTTP status code they are going to return. For example, the first class, namely 1xx, which is shortly referred to as the series that starts with 1, is primarily for informational status codes. This class is predominantly used for informational status codes. Next, the 2xx class is used to denote the success scenarios. In this case, we are going to mention from the server to the client that the request was successfully received and executed. The 3xx class is mostly for the redirection use cases. The 4xx class is used to capture the client-side errors when the client sends a request. Finally, the 5xx class is used to capture the server-side errors and signify to the client that these errors had happened at the server side. Let's look at each of these classes and their commonly used HTTP status codes. First, we have the 2xx class that is used to capture the successful status codes. In this case, the 200 OK is used to signify to the client that the request has been successfully received and processed at the server. The 200 OK is the most frequently used status code among all the status codes. Next, if the server has created a new resource at its site, then it can return the 201 created status code. Lastly, the 204 no content is used whenever the server wants to signify to the client that the request has succeeded and there is no response body for it. The next set of classes is 4xx, which is used to represent the client-side error status codes. Among these, the following are the most important ones that you need to remember when you are designing and implementing for the client-side errors. The first one, namely 400 bad request, is the most frequent one among these 4xx series. This is used to convey that the client has sent the request with details that are not expected on the server side. Maybe the parameters are not correct or it is in the incorrect format. In case the client is not authorized, then the server can return 401 unauthorized code. Next, the 403 forbidden status code is thrown by the server when the client cannot access this resource. The infamous 404 not found is used to signify to the client that the specified URL is not implemented on the server side. Finally, the 405 method not allowed is used to represent that the method that is being requested by the client, namely get, post, put or delete, is not allowed for this specific client. Finally, we have the 5xx class that is used to capture the server-side error codes. It is possible that sometimes some error happens on the server side as well. For instance, if there are some exceptions handled on the server side, then the server can return the error code 500 internal server error. This is the most common error returned from the server whenever there is an unknown error or unspecified error occurred at its end. In case there are some models that are not implemented at the server side and the client has requested for it, then the server can throw 501 not implemented error code. In short, any error in the 500 series signifies that it's a problem with the server, whereas any status code in the 400 series signifies a problem on the client side. In this lecture, you will get an overview of the Open API document that will be used as a reference to implement the API in this course. Open API is an open standard to design and expose RESTful APIs. This Open API document was created in my Open API specification for software developers course. In case you need to learn more about it, you can check out that course. For this course, we will be using this Open API as the base to implement the RESTful APIs exposed in this document. Let me give you a quick overview of it. This document shows the endpoints, the set of resources, and the methods required for a college management system. It has got two resources, namely courses and students. The course resource contains a set of paths defined to work with courses. First, we got a get operation that fetches all courses present in the system. Next, the post operation will be used to add a new course to the system. The next two set of operations are for an individual course: get, put, and delete. Finally, it exposes two operations for students belonging to an individual course. For each of these operations, it includes finer details such as the parameters to pass, the responses, request body, example values, and so on. Next, it shows the list of operations for the student's resource. This includes get and post for student collection, followed by get, put, and delete operations for an individual student. We will be implementing the operations under the courses path throughout this course. Those that are under the students path will be provided as assignments for you to practice the learnings from this course. As a next step, let us start implementing these APIs by creating a new ASP.NET Core Web API project. Let us start with step 1, creating a new Web API project. I will be using Visual Studio Code for this entire course. To begin with, go to the File menu and then Open Folder. This is going to pop up the folder selection dialog. I typically store them under Documents and My Codes folder. Let me create a new folder, CMS Web API. Once I selected it, the same will get opened in Visual Studio Code. This folder will act as a root folder for all the projects that are going to get created from now on. First, we need to create the Web API project. For this, I am adding a new project folder with the name cms.webapi. Once done, I am opening up the terminal to run the .NET command to create a new Web API project. If we type the .NET new --list command and execute, it will show us the list of all possible project types that we can select. This includes the project types for developing web applications, MVC applications, and so on. We are more interested in this specific command, Web API, that caters to developing web APIs. Hence, to create a new Web API project, you need to execute .NET new Web API command. It will take a couple of seconds to create the required files. Once done, if you now expand the cms.webapi project folder, you can see the .NET has created some default files for the Web API project type. The startup.cs file includes the important methods, namely configure services and configure. They are used to configure the basic settings for the Web API project. We will cover more about this in the next lecture. Next, the program.cs file contains some code snippet to start the application and create a host. Finally, the template has created a demo model, weather forecast, containing weather details, and a demo controller, weather forecast controller, that shows a sample usage of the controller and an action method. This get method generates some sample weather forecast values and returns to the caller. Let's see what happens if we run this application now. We go to the terminal and execute .NET run to start this web service. Now, the service is running and started listening at the port 5000. To check the API usage, we are going to use Postman. I strongly recommend you to use Postman when you want to work with APIs. In case you don't have it installed yet, go ahead, download the setup and install the same. Once you launch it, you can see its homepage. I have opened my workspace that contains the APIs that I use for my courses. Let us create a new collection to hold all the APIs that we will be building throughout this course. Click on New, then Collection, followed by giving a name to it as CMS Web API. To create a new Web API request, click on the Add a Request link. Here I enter the name as Weather Forecast, select the operation as GET, enter the URL as HTTP localhost followed by 5000. This is followed by the controller name. The controller name refers to the resource or endpoint that we intend to expose to the clients. In this case, the controller name is Weather Forecast. Once entered, hit the send button to execute this API request against our web service. The web API request gets executed successfully in the weather forecast controller, and it had returned a collection of sample weather forecast details to the client. We can now extend this web API project to include our own business logic. In the next lecture, we'll go through the different parts of a web API project so that you understand the basics of web API a lot better. In this lecture, we will dig a bit deeper to understand the inner workings of a web API service in ASP.NET Core. A good understanding of these will give you a strong foothold in mastering web API. Before we proceed, I want to convey that the concepts we are going to cover are all available by default in the project. You do not need to create them manually. You just need to plug in the required components as and when needed. First, we have the host created in the program.cs file. The host encapsulates the app's resources such as HTTP server implementation, logging, dependency injection, and so on. There are two methods that define the behavior of the host: the create default builder and configure web host defaults methods configure a host with a set of default options. Once done, the following features are available automatically to your web API project. It enables using Kestrel as the web server, enables IIS integration, and finally automatically loads the configuration files. For example, appsettings.json. Next, we have the startup.cs file that contains some of the core functions. This brings us to the second important concept in ASP.NET Core Web API, namely services. These are the set of services required by the app that is defined in the configure services method. Whenever you have a service that should be available throughout the project, you can add them to the service collection. Once added, they can be accessed from the individual classes through dependency injection. In your newly created project, currently contains code that adds controllers and Swagger to the service collection. You can add your own set of services within this function at any point in time. Dependency injection is a third core concept of the Web API project. ASP.NET Core supports a built-in dependency injection framework. The required services are configured in the configure services method. Once added, they can be resolved in classes using constructor injection. In the current project, we do not have any custom services added yet. We will be adding the database repository service to this collection in the next section. Next, we have the middlewares to be configured in the system. The request handling pipeline is composed of a sequence of middleware components. They encapsulate all HTTP specific information about an individual HTTP request. Whenever a new HTTP request is made, it flows through each of these middleware operations one after the other. As you can see, it follows the top-down approach. The individual middlewares are typically added through use methods. The default code contains the middleware that is related to development, Swagger, HTTP redirection, and so on. Finally, we have the routing concept, which is fundamental for any web API project. A route is a URL pattern that is mapped to a handler. Hence, whenever a request is made from the client, the server will try to match that URL against the handlers configured in the system. To enable routing, you need use routing to the configure method in startup.cs. Note that once you have enabled routing using use routing, you should configure the mapping information using use endpoints. Here you can notice that the map controllers is used to signal ASP.NET to use the routing information configured in the controllers and their operations. For the weather forecast controller, the routing is configured using the route attribute. You will be learning about routing in the later part of this course. As I said before, do not worry about all these concepts. They are all available by default in newly created Web API project. You just need to concentrate to understand these concepts before we proceed further. Let us quickly summarize the concepts that you have learned in this Getting Started section. First, you got an overview of a typical HTTP request response cycle. The client sends an HTTP request to the server. Depending upon whether the request had succeeded or failed at the server, the response is formed and returned to the client. Next, you got an overview of the common Web API operations. They are get, post, put, delete, and patch operations. The get operation is used to fetch details from the server. The post and put operations for adding a new resource and updating an existing resource respectively. The delete operation is used to delete a resource at the server end. Next, you understood the different types of HTTP status codes. For successful request execution at the server, you can use the 200, 201 and 204 status codes. In case the request from the client is not proper, then you can return error codes in the 400 series such as 400 bad request, 401 unauthorized and so on. Finally, in case the fault is at the server end, you can return 500 internal server error or 501 not implemented status codes. You then were presented with an existing OpenAPI specification of college management system. We intend to implement this API in this course. You then took the first step of creating a new Web API project in ASP.NET Core using .NET new Web API command. In the next section, a closer look at API controller. We'll go deeper to learn more about API controllers that are fundamental for any API projects. Hi, I am Praveen. Thanks for watching this video. This lesson is part of the hands-on ASP.NET Core Web API project, a guide to building a Web API in ASP.NET Core through a step-by-step process. In this course, you will be learning to build the ASP.NET Core from the scratch using the various technologies available in ASP.NET Core. To have the best learning experience, I strongly recommend you to enroll in this course so that you can learn to build the Web API from the scratch. In case you need more time evaluating the content, feel free to continue watching this video. I hope to see you in the course. Thank you. In this section, a closer look at API controllers, we are going to go deeper into knowing more about the API controllers. First, you will understand more about controllers in ASP.NET Core. This is followed by understanding more on attributes. Finally, you will get to know the significance of the API controller attribute. Let's get started with what controllers are. Any Web API project consists of one or more controller classes. These are special classes that handle Web API requests. Remember that when you are working on an ASP.NET Core Web API project, the main objective is to expose and implement API endpoints. You do so using one or more of these controller classes. In ASP.NET Core Web API context, they are classes that derive from the controller base class. If you remember, the views in ASP.NET Core are derived from the controller class. However, for Web APIs, you derive it from controller base class. A simple way to remember this is derive your class from controller base if using only for Web API. If using for both views and Web APIs, then you can derive from controller class. Since most of the API developers will be using it to work with Web API, they almost always end up deriving from the controller base class. In our project, you can notice that our controller class derives from the controller base class. You might be wondering what is the significance of this controller base class. The main advantage is that it provides various methods and properties that are related to HTTP requests. In the past section, we covered various HTTP operations such as get, post, put, delete, and so on. Also, we covered various HTTP status codes such as 200, 201, 400, 404, 500, and so on. The controller base class provides the corresponding methods such as bad request, not found, and so on that can be returned by the server to the clients. We will cover them more in the later part of this course. The other important part of Web API projects is the attributes. Although attributes can occur in many places in .NET, they play a pivotal role in the case of ASP.NET Core Web API projects. Attributes are used to configure the behavior of Web API controllers and their action methods. You can change the behavior of API controllers to suit your business needs through these attributes. Some of the common attributes used with the controller classes are API controller, root, etc. API controller attribute is applied for all controllers that are related to Web API. This is the most powerful attribute when working with Web API projects. In fact, a separate lecture is dedicated and created to cover the role played by the API controller attribute. The root attribute is used to mention the path of the URL for an action method. The courses controller class has the API controller and root attributes applied by default. For the root attribute, you can key in the relative path of the URL. Also, you can mention the keyword controller in square brackets. In such a case, ASP.NET will use the class name prefix used to define the controller class. I generally use this notation so that I am not hard-coding the class name. Even if I change the class name in the future, it will not break my routing attributes. Some of the common attributes used with the methods are HTTP get, HTTP post, produces, consumes, etc. The HTTP get and HTTP post attributes are used to tag methods for the get and post operations respectively. Moreover, produces and consumes attribute assist to mention the type that is returned and accepted by methods. In the next lecture, we'll look at the crucial role played by the API controller attribute. Let us see that next. In this lecture, we'll look at the significance of the API controller attribute. This attribute is so special and important that it warrants a dedicated lecture. The application of the API controller attribute to a class brings in various features to your ASP.NET project. Let us look at each one of these one after the other. Firstly, when the API controller attribute is applied to a controller class, it provides API specific behaviors. You can apply this attribute either at the class level, base class, or even at the assembly level. When applied to an individual class, the attribute is applied only for that class. For example, I have applied the attribute at the class level. However, if you want to apply for multiple classes, then you have an option of applying for a base class and then letting your other classes derive from it. Also, you can apply it at the assembly level over the namespace of the startup class. In such a case, it applies to all controllers present in that assembly. For the current project, I have applied this attribute over the cms.webapi namespace that is enclosed over the startup class. I did this just to show you how to apply it at the namespace level. Personally, I recommend you apply the API controller attribute at the individual class level so that you get better control over it. Secondly, this attribute makes the routing mandatory through the route attribute. We had set the route as root followed by the controller keyword in square brackets. Once done, the actions cannot be accessed through other means such as from use endpoints. You can notice in the startup class that the use endpoints don't have the manual routing defined. We have let the mapping be handled by the individual controllers. Thirdly, the API controller attribute enables automatic HTTP 400 bad request response for relevant scenarios. The runtime makes model validation errors automatically trigger an HTTP 400 response whenever the data sent in the request is not correct. Hence, you no need to check the state of the model before its usage. For example, this code snippet shows the model state usage commented out, as this is not required once you have the API controller attribute to its class. It makes your life a bit easier. Fourthly, the API controller attribute supports binding sources for parameters. As you will be seeing throughout this course, operations can accept parameters. API controller allows you to mention the source of such parameter values in the HTTP request. The allowed attributes are from body, from query, from root, and so on. API controller uses inferring rules to automatically bind sources. The complex parameters are bound to from body, followed by the same name parameters are bound to from root. The last option is from query. Next, the API controller attribute provides default problem details for error status codes. For example, if you want to return an error for the 404 status code, then you can directly return not found instances that refer to the problem details type with the error details. Finally, the API controller attribute allows you to mention the supported request type using the consumes attribute. It can be applied either at the controller or at the action level. I understand some of these concepts might be difficult to digest at this point. Do not worry. We will be covering all these concepts then and there. By the end of this course, you will be comfortable with these concepts. Let us summarize the key concepts that you had learned in this section, a close look at API controllers. First, you learned that the controllers are special classes that handle Web API requests. In ASP.NET Core Web API context, they are classes that derive from the controller base class. The main advantage is that it provides various methods and properties that are related to HTTP request. Second, attributes are used to configure the behavior of Web API controllers and their action methods. They can be applied to both controller classes as well as their action methods. Root, produces, and consumes are some of the attributes you can apply to your controller class. On the other hand, the action methods can have HTTP get, HTTP put, HTTP delete, and so on. Finally, the application of the API controller attribute to a class brings in various useful features to your ASP.NET project. They provide API-specific behavior to your class. You can apply this attribute at individual class, base class, or even at the assembly level. It enforces the usage of mandatory attribute routing for your controller class. Further, any bad request from the client triggers an automatic 400 bad request response to the client. Moreover, it supports binding the parameters for actions from various sources such as from body, from path, from query parameters, and so on. Finally, it supports providing default problem details for error status codes and usage of consumes attribute to capture the list of types accepted by it. In this section, implementing collection APIs, you will learn the steps to be taken to implement a collection API in your project. The collection API refers to an endpoint that returns a list of items for a resource. For example, a list of courses present in the system. In the previous section, we created a new Web API project as step 1. As the next step, you will learn how to add a new controller to your project. Next, in step 3, we will add some actions to this controller class. This is followed by adding data models to the project as step 4. We then move towards the database layer, wherein we add the database repository and use that newly created database repository. Finally, we will look at implementing a get operation to fetch all items from the system. By the end of this section, you will be familiar with creating controller classes and adding action methods with basic implementation. Let's get started with adding a new controller to the project. In this lecture, you will add a new controller to the Web API project that will be used to work with courses. Currently, you have the weather forecast controller that was created by default by ASP.NET Core. Since you do not need that, just delete it from this project. Next, right-click the controllers folder and select New C# class. Give the name as coursescontroller.cs. This will create a blank C# class file with courses controller as the class name. The first step when working with a controller class is to make it derived from the controller base class. This signals the ASP.NET Core that this class will be used for Web API development. Next, create a constructor for this class that will be used in the later part of this section to implement dependency injection. You can leave it blank as of now. Secondly, add the API controller attribute to this controller class. As explained before, this will provide Web API specific behavior for this class. Once it is done, add routing information for this class using the route attribute. Keep the route parameter as simple as courses. If you notice carefully, here the path name is hard-coded. In case you change the resource name or class name in the future, you need to remember to change this hard-coded value. A better approach is to use the controller keyword inside the square bracket to keep the name generic. In this case, ASP.NET Core will pick the path from the prefix of the class name. I strongly recommend you follow the same convention to keep your code clean. For the courses controller, the prefix before the controller keyword is courses. Hence, the courses will be considered as the root path for this class. Visual Studio Code will show errors as we need to add appropriate namespaces. All these API related terms such as controller base, API controller, and root are available under Microsoft.aspnetcore.mvc namespace. Once this namespace is added, these errors will then get resolved. You can then go ahead and build this project using .NET Build. The project should build without any errors. Once the controller is added to the project, your next step is to add actions or methods to this controller class. Let's do that next. The next step is to add actions to the controller. Actions are the methods or operations that are defined in the controller classes. When a client sends an HTTP request against API methods, the corresponding methods get triggered for execution. The most commonly used action attributes are HTTP GET, HTTP POST, HTTP PUT, and HTTP DELETE. These corresponds to GET, POST, PUT, and DELETE HTTP operations. Depending upon your requirement, you will be implementing one or more of these actions in your controller class. For the courses controller, you can add a new method getCourses that returns the list of courses in the system. Public string getCourses. You can just return hello world for now to check its behavior. It will be extended to return actual courses shortly. Since the purpose of this action is to fetch resources from the system, you can add the HTTP GET attribute to it. One point to note here is that if you don't mention any attribute to an action, then it is considered to have HTTP GET implicitly. However, I still recommend you to include HTTP GET for such methods as it aids in clean coding and better understanding of your code. Next, build the project and make sure there are no errors. Once it is built, go to Postman, add a new request for getCourses. Set the operation as GET, enter the URL as http localhost 5000/courses. Hit the send button to execute this against your web service. You can then see the hello world message received from the server in the Postman output. Next, go back to your code, comment out the hello world statement and change the return type as IEnumerable of course to return a list of courses. Once you have made sure the action is added properly to the controller, the next step is to add appropriate data models to your project. Let us do that next. In step 4, you add the required data models to your project. Since this involves interacting with the database layer, I recommend you to have them in a separate library. Create a new folder cms.data.repository. Open it in terminal and create a new class library at this location by executing .NET new classlib command. This will create necessary files to form a class library that can be referred to in your Web API project. Delete the class.cs file that was auto-generated. Create a new folder models to hold all data models in this class library. Add a new C# class named course.cs that will be used to create a new data model named course. It is time to add the required properties to this class to define the course type. You can configure with just the basic details required to represent a course type in the system. This includes course ID as integer, course name as a string, course duration as an integer that will hold the course duration in years, and finally an enum course type that will hold the type of the course. Next, define the course type enum by giving the values as engineering, medical, and management. For now, the course model is sufficient for the Web API server. The next step is to add a database repository interface and implement the same using the newly defined course model. Let us do that next. As the next step, you add the database repository to the cms.data.repository class library. First, create a new folder repositories that will be used to hold all the repositories created in this assembly. Then add a new interface iCMS repository. Next, include the first method to this interface IEnumerable of course get all courses. It is recommended to expose the repository as an interface. The advantage of such an approach is that you can implement this interface in multiple ways. To begin with, you can add an in-memory repository that will hold the data in the memory. This is used just for the demo. Make it implement from the iCMS repository interface. Next, add a default constructor public in-memory CMS repository. Also, implement the get all courses in this in-memory repository. Currently it is blank. It will be implemented shortly in the forthcoming lecture. Since the repository is exposed as an interface, in the future you can implement the database layer that interacts with an actual database such as a SQL server. During that time, you can add a new class SQL CMS repository that implements the same iCMS repository. This class can then be implemented to use Entity Framework or any other technology to interact with the SQL server. Once the database repository is created, the next step is to use it in the main cms.webapi project. Let us do that next. You typically use a database repository to connect to the database and interact with it when working with web APIs. In this step, you will use the in-memory repository that you had created in the previous step. First, you need to add the iCMS repository into your courses controller class. To do this, add an instance of this as a parameter to its constructor. This parameter will be populated through dependency injection by ASP.NET. A local variable CMS repository is created to hold this repository instance. You will be using this instance whenever you need to interact with the database, be it to fetch the details or add new entries to the system. It should give you a warning that the class library is not added yet to this project. Add the cms.data.repository class library to the cms.webapi project by running the command .NET add reference followed by the relative path of the CS project file. Once added, you can use the using statement to bring in the CMS repository namespace into this main project. Second, you use this repository to fetch the course details inside the getCourses method. You had created a dummy getAllCourses inside the in-memory CMS repository class, the same to be called from this method. Bring in the namespace for the IEnumerable type as well as for the course type. Next, you need to add the repository instance to the service collection. As explained before, you need to do this in the configure service method of the startup.cs file. Since you want a single instance of in-memory repository to be created so that the same gets accessed throughout the application, use the add singleton method to add a mapping between iCMS repository and in-memory CMS repository type. You need to bring in the appropriate namespaces as well. Next, build the project to look for any errors in the solution. Okay, there are some errors. Let us check them out. Looks like the namespace for IEnumerable is missing in some classes. It looks fine in the courses controller.cs file. You can notice the Visual Studio Code highlighting the files that have got the error. If you check the iCMS repository.cs file, you will be seeing the error against IEnumerable here. Fix it by adding the appropriate namespace, followed by adding the namespace for the course type. Next, you need to return a course list from the getAllCourses method. For now, you can just return null. You will be populating this with the actual list in the next lecture. In the same way, fix the errors for the SQL CMS repository class by adding appropriate namespaces for the generic list and course type. Make the getAllCourses return null as a temporary placeholder. This should resolve all the errors that were shown initially. If you build the project now, it should not show any errors. In this step, you have used the newly created database repository in the Web API project. The next step is to implement the get method, namely getAllCourses, to fetch all the courses present in the system. Let us see that next. In this step, you will use the repository that was created in the previous step to get the list of all courses available in the system. First, go to the in-memory CMS repository class and declare a new instance for list of courses. This will be used to hold the collection of all courses in the system. Next, in the constructor, create the instance for a list of courses type. For this demo, we will add 2 course entries to this collection so that you can see the same as the output from this Web API. Begin by adding a new instance of course with the course ID as 1, course name as computer science, course duration as 4, that represents the number of years, and finally the course type as engineering. Once this is done, create the second course entry. You can just duplicate the previous one and update only the ID as 2 and the course name as information technology. The course duration and course type can remain the same. Next, update the getAllCourses method to return this course collection instance. This completes implementing the getAllCourses method in the repository. Next, go to the terminal and run the Web API service. Once it has started, it will be listening on the port 5000. Go to Postman and execute the get request for the course resource. It will show you the list of courses that you have just added to the repository. Coming back to the code, one point to note is that the course that was defined inside the cms.data.repository class represents the data model. This is used to represent the data that has been stored in the database. When you are working with data models in the Web API, it is recommended to have data models and data transfer objects separately. The data transfer object refers to those models that are used in the Web API to expose to the clients. The main difference between data model and DTO is that the data model is going to replicate the exact database schemas most of the time, whereas the data transfer objects shortly we call as the DTOs, will contain only those properties that you want to expose to the clients. This way, the data layer is separated from the business layer. As the next step, you need to create a DTO for the course type and replace the same in the courses controller class. To create the DTOs, go back to the cms.webapi project, create a new folder, namely DTOs. Inside that, create a new file named coursedto.cs. You can copy paste the same models from the repository and then update them as per the business requirements. For this demo, you can leave it as is, since the data model contains only a minimal set of information whose details are all required to the client as well. Next, go to the courses controller and add a new method to map the course to course DTO. This is required so that the data model is converted back to an instance of DTO before it is sent to the client. You add a new method map course to course DTO that accepts the course data model and creates a new instance of course DTO with the value from the course data model. The properties, namely course ID, course name, course duration, and course type are initialized. Next, go to the getCourses method to update the return type as IEnumerable of course DTO instead of course. To do this, I am going to take a backup of the existing code so that you can use it as a reference when you want to check the code that you have written before. Once you go to the duplicated code, remove the return statement. Let's wrap the entire code inside a try-catch block so that you can handle any exceptions occurring within this method, followed by returning an appropriate error status code to the client. The body of the method to be updated to fetch all courses from the repository and assign it to the IEnumerable course instance. First, you need to get all the course details from the repository. For this, use IEnumerable of course, courses equals cms repository dot get all courses. Note that this is going to return all the courses of the type course data model. You need to map this to the respective course DTO before you can return this to the client. To do this, you use the map course to course DTO method that was written before. However, you get an error. The reason being, this method accepts only an individual item, not a collection. To handle this, you can create an overloaded method for this method that accepts a collection. You will be requiring the old method that accepts a single instance at a later point when you are working with put and post operation. Go down, duplicate the map course to course DTO method, make it accept course collection as the input, and update the return type as course DTO collection. Inside the body, declare the result variable of type IEnumerable course DTO. Next, assign this to courses collection using a link query. Result equals courses.select. We are going to use a link query to navigate through each of the instances of the course and then convert it into course DTO type. C goes to new course DTO, course ID equals course ID, course name equals course name, course duration equals c.course duration, and finally course type equals c.course type. Once this is done, you can remove the temporary code that was written before and then return the result from this method. Of course, you need to add a namespace for bringing in the link capabilities for this project. As the final step, go back to the getCourses method, update the method to use map courses to course DTO method that accepts a collection and return the result. If you now run the project and then go to the postman and then hit the send button, it is going to return the same set of course details that was configured in the source code. However, the main difference here is that it is coming through proper segregation of data models in the repository and data transfer objects in the controller. This completes the implementation of the get operation to fetch all details from the system. Let us summarize the key concepts that you had learned in this section, implementing collection APIs. Throughout this section, you have taken further steps to work with ASP.NET Core Web APIs. First, you added a new controller and learned that you need to derive it from the controller base class. This ensures you get Web API specific behavior to your project. Also, you use the route attribute to define the routing for accessing this newly added controller endpoint. In step 3, you learn to add actions to your controller to define the behaviors for the controller. You apply appropriate attributes to the method to implement the behaviors. Some of the commonly used attributes applied to actions are HTTP GET, HTTP POST, HTTP PUT, and HTTP DELETE. As the next step, you added data models to the projects. These are the classes that mirror the database and the tables that your resources represent. You created these data models in a separate class library to keep the data layer and business layer separate. Moreover, you added a database repository to interact with the database. For the current project, you added an in-memory repository that holds the data in the memory of the application. You learned the advantage of using an interface as the database repository so that you can define multiple repositories that cater to different database types. I used to use Entity Framework when working with customer projects at work. This was followed by using the database repository in the controller using dependency injection. Finally, you implemented a new GET operation for the courses controller class to fetch all the courses present in the system. You understood the difference between a data model and data transfer object from the perspective of web APIs. The data transfer objects are client-facing, whereas the data models are for database tables. You had used a custom mapper method to map data models to data transfer objects. Now, you will be familiar with creating controllers and adding GET methods to them. Practice the learnings by adding more GET methods to the controller and notice what happens in those situations. In the next section, a closer look at return types, you will be introduced to the different approaches of returning a value from an action. This will help you to decide on choosing the right return type for the Web API methods. See you in the next section.
Hi, I am Praveen. Thanks for watching this video. This lesson is part of the hands-on ASP.NET Core Web API project, a guide to building an Web API in ASP.NET Core through a step-by-step process. In this course, you will be learning to build the ASP.NET Core from the scratch using the various technologies available in ASP.NET Core. To have the best learning experience, I strongly recommend you to enroll in this course so that you can learn to build the Web API from the scratch. I hope to see you in the course. Thank you.